Okay, I've got to show that this equation can be expressed in this form. I want to use that. I've got tan x. I don't want to get rid of the tan x's because I've got them in here. So I'm going to multiply through by tan x to start with. So part 1 can multiply through by tan x, and that's going to be tan x times the sine x minus tan x times the cos x equals 6 cos x. I can see the 6 is quite nice. I've got a 6 here. It's got no cos x's in there, so actually I'm going to divide everything through by cos x, and that will give me tan x, and then it'll be sine x over cos x, which is tan x, minus tan x, and cos x over cos x is 1, so it'll just be the tan x, and that'll equal 6, and that basically gives me my thing I wanted to find. Okay, so it's got that. It gives me 2 marks. I've now hence solved this equation, so I've got exactly, always just check that it's exactly the same equation as I had here. It is. So basically it wants me to solve, it's this bit here. It's a quadratic in tan x. So you could do it, let's tan x equals y, and then you get y squared equals that. Personally, I don't like doing it that way. If I can see it automatically, and I can in this particular case, because I've got to get tan squared x. So one bracket has got to be tan x, and the other bracket has also got to have tan x in it. And what's the numbers? I've got to get 6. So this number times this number has got to be 1 and 6, or 2 and 3. And I want to get minus tan x, so that's minus 1 tan x. So obviously it's not going to be 1 and 6, it'll be 2 and 3. So I'm going to put a 2 and 3 in. It's minus 6, so one's going to be positive and one's going to be negative. And I want it to be minus tan x, so that's going to be the bigger one's going to be minus, and that one's going to be positive. And now I've got something times something equals 0, so I always like starting with the word either, because either the first one, tan x plus 2 equals 0, or the second one, which is tan x minus 3 equals 0. And now I just have to solve those. Tan x equals negative 2, or tan x equals 3. Just solve those ones. So I'm just going to check to see what my solutions need to be for 0 and between x is between 0 and 360. Right, so what have I got? So I'm going to get x equals tan to the minus 1 of negative 2, or x equals tan to the minus 1 of 3. I'll do the 3 one first, so that'll be x equals 71.565, and that repeats every 180 degrees. So put 180 n degrees. And so this could be, x could be 71.6. Or if I add 100, if n's 1 and add 180 to it, or that will give me 251.56. Okay, this one here, that will give me x equals, according to my calculator, it's minus 63.434, but that will also increase every 100 by 180 n. So every 180 degrees we get the same answer, and that of course comes from the unit circle, Hartley central, sine in the middle, up the top axis, cos over here, and tan is the gradient, because that bit, the up bit there, will be the sine value, and the cross bit here will be the cos value, and the blue divided by the pink will be the up divided by the across, which will be the gradient, and the gradient of this will be tan. And that obviously repeats every 180 degrees, because that bit and that bit are the same. So there we are. So what could it be? I could get x equals, I can't get minus 63 because that's not above 0, so I'd have to add 180 onto that, which gives me 116.56, or add 360 onto it, which would give us nearly 300, which is 296.56 degrees. And then I want to put them into, I normally put them into order, so x equals 71.6, or the next one will be this one here. We want to give 3 significant figures, so that would be 117 degrees. I always feel strange giving an angle to one decimal place and then to like this, but this is what they expect. Next one will be 252 degrees, or finally, that would be 297 degrees. And that's question 4 done.